we're going to do is we're going to look at Chapter 1, Section 2. This chapter works with segments and congruence. There's a couple of definitions that you need to know. The first definition that you need to be aware of is postulate or axiom. This will show up on the quiz or test, so it's a good definition to know. What it is, it's a rule in geometry that it's accepted without proof. We don't ask questions about it. It's just this is the rule. The second definition we're going to look at is distance. And the distance is between 2 points and is the absolute value of the difference. And so you can go, well, Mrs. Medvick, I don't understand. If I'm going to go from A to D, why can't I just count it? Well, sometimes they don't have a number line there. And so if you have this formula to use, you don't have to sit and draw it. It actually saves time in the long run. So an example of how you're going to do this in your notes is you're going to take the absolute value. So nice, tall, straight line, the first part of the absolute value. I'm going to take A, which is -8. And then what I'm going to do is I'm going to put a subtraction sign between it because it's the difference of the two. And then I'm going to take the other number, which is 3, and close it with the absolute value. And then I'm going to keep going and do the absolute value of 8 minus 3, which is -11. And then I'm going to go ahead and follow it through. So it's 11 units. And that's how you're going to show the work on these problems. Okay, let's move on and let's go to the next one. We've got B and C. So again, I'm going to take the absolute value. I'm going to grab my B, which is -5. I'm going to subtract the value of C, which is 0. So the absolute value of -5, and I end up with 5 units. So when you do these on your assignments and your quiz and test, this is how I would like you to do those. It's also really good practice when we do absolute values. All right, segment addition. Segment addition is something we're going to use a lot this year. What it's saying is that if I have B and it's between A and C, then if I take AB, this measurement, and I add BC, that gives me the whole thing. It's kind of like duh. If I take one little segment, another little segment, and put them together, it's going to equal the whole piece together. Let's go ahead and let's use this then. Again, we're going to use this a lot, and it's really easy at first, but then it gets to be more complicated when we're looking at proofs. So the question it's asking me to is to solve for x. And so what I'm going to do is I'm going to take MZ, which is 3. I'm going to add ZP, which is 12, and that's going to give me X. Notice that I'm putting it together this way. Make sure you put it together this way because this is segment addition, and it's going to help you with proofs. And so if I follow it through, 15 equals X, or X equals 15 units. So this is the way I would like you to show work and use algebra. The second problem, we're also solving for X, but you'll notice it's a little bit different. I'm going to take 4x minus 2. I'm going to add 3x. So I took this segment and I added this segment, and it gives me 26. So on a proof, you would say segment addition. Then what you're going to do is you're going to combine your like terms. And again, this is something students tend not to want to do. They want to add the two, and don't do that. Please combine like terms. So I'm going to go 7x minus 2 equals 26. Then I'm going to add my 2. 7x equals 28. And x gives me 4 units. Notice that I didn't put any work in between each of these. What I did was I just went ahead and I did the work like kind of in my head. That's something that's going to help us when we get to proofs. Make sure also too that you don't skip steps. So you'll notice this step, I combined like terms, then I added, then I divided. Do one thing at a time. Don't do like add to and divide all on the same step. All right, let's move on. Here's another example. It says RY is a segment with S in between. Solve for Y. Note, and this is key, drawing a picture. So I want you to draw a picture when you do these. So this is R, y. And S is somewhere in between. It doesn't say directly in the middle. I'm just going to call this S. So if I take a look at RS, that is 4y minus 1. Then I'm going to do SY, and that is 5y plus 5. And then this whole thing is 85. Notice that when I draw a picture and I put those things in, it just pops and it becomes easier for you. So I'm going to take 4y minus 1. I'm going to add 5y plus 5, and I'm going to set it equal to 85. Now I'm going to combine my like terms. So notice that I got two y's on the same left side, 9y. Then I take my negative 1 and my 5, and I get plus 4, and I get 85. So again, you can bring that all together on one step and say combine like terms. Now we're going to subtract our 4, so 9y equals 81. Then I'm going to divide, so my y equals 9, and it's going to be 9 units. Note that when two things are congruent to each other, it means that they're the same or equal. So here's a definition. Congruent just means same or equal. And the symbol for congruence is this. Most of the time when I'm talking about congruence in class, I'll say like line segment AB is congruent to line segment CD. Or I'll say angle A is congruent to angle B. So that's how we use congruence. When we look at equality and talk about equals, I would say like 3 is equal to 4, or I'm sorry, not 4, but 3. Or I could say the measure of angle A equals the measure of angle B. Notice the difference. I'm actually dealing with a measure or a number for equality, and I'm working with symbols when I'm looking at congruence. All right, here's an example. Plot the following points in a coordinate plane and determine whether the line segments are congruent. So the work that we do on this is really important, so pay attention to how I do this. So first of all, J is negative 3, 4. So negative 3, 4 is right here. I'm going to call that J. And then I'm going to grab K, which is 2, 4. 2, 4. So this is K. Right? Now what I'm going to do is I'm going to grab 1, 3, which is L. And I'm going to grab 1, negative 2, which is M. Here's another line segment. So what it's doing is it says, tell me, are they congruent or are they equal? Again, we're going to grab some of the stuff that we learned before, where I'm going to take JK. I'm going to do the absolute value. Now you can say, well, which values do I grab for this? Do I grab the X value or do I grab the Y value? If you take a look at these two ordered pairs, you're going to notice that the Y values here and here are the same. So if I subtract those, it would be 0, and we don't want to do that. So what I'm going to do on these is I'm going to grab the negative 3 and the 2. So I'm going to grab negative 3 minus 2. It's the absolute value of negative 5, and I get 5. Now I'm going to grab the other one. I'm going to grab LM. And when I look at LM, if you take a close look, you're going to notice that I've got the ones that are the same. So I'm not going to grab those numbers. I'm going to grab the 3 and the negative 2. Because when I subtract them, I need a number that's not 0. So I'm going to grab 3 and negative 2. So I'm going to come back. And again, this is line segment LM. I'm going to do my chop, chop. And you're going to notice that they are the same. So the question states, determine whether the line segments are congruent. And we can go, yes, JK is congruent to LM. Make sure that you show your work using your absolute values, and make sure that also you're grabbing the right numbers so that when you subtract them, they don't equal 0. All right, that's it for this section. If you have any questions, please definitely email me. Let me know if you have any questions.